Okay, so now we're going to try some practice problems, and this will help prepare you for the homeworks. If you have any questions, this video key hopefully will help kind of explain how to work through the problems. And of course, there's office hours too, and you can always email me. So we start off with this first problem. It wants to know, does this particular series converge? And if it does, what does it converge to? So the first thing I'm going to do is I'm going to see that it doesn't converge, right? So first we're going to test for non-convergence. And we're going to do that by taking the limit as n goes to infinity of the summand, right? So we're going to look at the limit of 7 over 8 to the n. All right, of course the 7 comes out. And the limit as n goes to infinity of 1 over 8 to the n actually is 0. So the test is inconclusive. We can't say for sure that it doesn't converge. Now you might have looked at this and you might have known the answer already because you realize this is a geometric series. So if we think about this, this is a geometric series. And I can simply apply the formula for the geometric series. So we recall this is an important result, so I'm going to write it in red. Something that we want to remember, that if the absolute value of r is less than 1, then the infinite series from n equals 0 to infinity of r to the n is 1 over 1 minus r. So this is the result that we're going to apply. And what I'm going to do to put my series in that form is I'm going to factor out the 7. So I'm going to realize that I can write s, in our case, I can always factor out a constant, so I'm going to factor out the 7. And then I'm going to realize I can put the remaining terms as the sequence 1 over 8 to the n. And I'm starting at n equal to 0, so now I can apply this formula. So here my r is equal to 1/8. Okay. So this is going to be 7 times 1 over 1 minus an eighth. And I can see this will be 7/8. When I flip it, it'll be 8/7. And so my final answer ends up being 8. Now I look at the next problem, and it seems very similar, but notice that my starting index is not at 0. It's at 2. And so let's just kind of look at this. So we already know that this is a geometric series and it's going to converge, but I'm going to have to deal with the fact that I'm not starting at 0. So let's just kind of sketch out the first couple of terms. So the first term is 7 over 8 squared, right? Then it's 7 over 8 cubed plus 7 over 8 to the 4th, dot, dot, dot. And notice that in order to have a geometric series, and this is important, the first term always has to be 1. If you look at the first term, when n is equal to 0, r to the 0 is going to be 1. So I'm going to factor out a 7 over 8 squared, right? So if we go ahead and do that, this will be 7 over 8 squared. First term will be 1. When I factor out a 7 over 8 squared here, I'll have 1 factor of 1/8 left over. Here I'll have a factor of 1/8 squared. and that will continue. And so this will be the geometric series that we just evaluated here. So if we look at what we had before, this evaluates to 8 over 7. And what we saw from before, and here, let me just be kind of really explicit about this. So this portion right here, I had 1 over 7/8, and when I flipped it, it was 8/7, right? So this is the same as this, and it will give me 8/7. Okay. All right. And when all the mathematical smoke clears, we get 1 over 8. Okay. Now we want to look at the following series. We want to determine if it converges, and if it does, we want to evaluate it. Now, the first thing we should do is we should try the test for non-convergence, right? And moreover, if it does converge, we're probably going to have to use a telescoping series. But let's just kind of work through it one thing at a time, okay? So first, if we use the test for non-convergence, we're going to take the limit as n goes to infinity of the terms in the sequence. And we remember from Calc 1, right? This is a rational function. It's a ratio of polynomials. So I'm going to go ahead and I'm going to distribute. In the numerator, I'll get n squared plus n over n squared plus 3n plus 2. And we remember when we take limits at infinity and we have rational functions, we only look at the leading term, right? So here, the leading term is n squared in the numerator and n squared in the denominator. So this is going to be the limit as n goes to infinity of n squared over n squared, which is 1. And you remember what the test says. The test says that if the limit of the terms in the series do not converge to 0, if they're not equal to 0, then we know that the infinite series does not converge. Whoops. And this is exactly the situation we had here, right? So we find out the limit of the sequence terms in the series converges 1, which is not equal to 0. Therefore, this infinite series does not converge. Okay? And you can say does not converge, does not exist. It's really the same thing. This next problem is a sort of problem that we're going to see a great deal in the coming weeks ahead. This is the power series. Okay, so now we have this x in here being a variable, and we want to know for what values of x does this converge. So let me just make the observation that when x is equal to 0, okay, I'm going to get n equal to the 0, 3 times minus 1/2 to the nth. I may not know what this is right off the top of my head, but I do know that this converges, because this is going to be this I can re-express in terms of geometric sums, and we did a problem like this before, split apart the even and the odd terms, and I know that this is going to end up converging. So I see that for x equal to 0, it's going to work. The question is, what are all the values of x that it's going to converge? Well, if I look at this carefully, I realize this is actually a geometric series. if I look at this, I realize that I can rewrite S. I can factor out the 3. And I'm going to end up getting this. Okay. And this is like my R. So notice something that's a little subtle here that I'm sweeping under the rug slightly. This red infinite series is not a geometric series. Okay. However, as we showed before in video 3C, I can split apart the even and odd terms, and I can get a geometric series in each of those groupings of terms, right? Same sort of thing is going on here. Okay, so this is going to converge if the absolute value of R is less than 1. So we recall that. Only if the absolute value of R is less than 1. So in our case, R is equal to, well, it's the base, right? It's the thing that we're raising to the nth power. So it's going to be x minus 1 over 2. And so we're going to have convergence if the absolute value of R, which is the absolute value of x minus 1 over 2, is less than 1. And now I want to solve for x, right? So I'm going to use the fact that this is the same as saying I can drop the absolute values. If the absolute value of a quantity is less than 1, then the value itself has to be between minus 1 and positive 1. Okay. I can multiply both sides through by 2. And I can add 1. And that will be my final answer. Minus 1 is less than x is less than 3. Okay, so we look at this and I realize that I can split this apart into 2 separate infinite series, okay? So let's split this apart. Let's write S as so I'm just splitting this apart. Okay. And I'm going to call this S1. And I'm going to call this S2. And so S1 is actually quite easy. S1 is a straightforward geometric series, right? So if we look at S1, I can write it as 5 times the infinite series n equals 0 to infinity of 1 over 2 to the n. And here my R is 1/2. So it's going to converge, and I know what it's going to converge to. 5 times 1 over 1 minus R, which is going to be a half. And here I'll get a half on the bottom, and when I flip it, it will become 2. And so S1 will be 5 times 2, or 10. Now, if I look at S2, S2 again has these alternating signs, right? So I'm going to notice that at n equal to 0, I get 1. And then at n equal to 1, I get minus a third. And then at n equal to 2, I get minus 1/3 squared, and I'm going to make it positive 1/3. It won't matter because I'm squaring it, right? So let me just write it like this. And then I'm going to get minus 1/3 cubed. And we're going to play that same sort of game again. Okay, I'm going to split these two terms apart, the even and the positive and the negatives. And so if I look at the positive terms, it's going to be 1 plus 1/3 squared. And what I'm going to notice is that the power goes up by 1/3 squared. Okay, so I can really think of this as 1/9, and this is 1/9 squared. All right, so that's how I'm going to start to think about these terms. Okay, plus 1/9 squared plus dot dot dot. Because again, what's happening each time I'm multiplying the previous term by 1/3 squared, right? And by the same token, if I look at the negative terms, I'm going to get 1/3 plus 1/3 cubed plus 1/3 to the 5th plus dot dot dot. Okay, so these are from the positive terms, and these are from the negative terms. And now I can see what's going to happen. If I factor out a 1/3, I'm going to get the same power series. I'm sorry, I'm going to get the same infinite series that I get here. So what I'm going to do is I'm going to have 1 plus 1/9 plus 1/9 squared plus dot dot dot. And again, here I'm going to factor out a 1/3. If I want to change this into a geometric series, the first term always has to be 1, okay? That's kind of my guide here. The second term is going to be 1/3 squared, so I'm going to get 1/9. After I factor out the 1/3 here, this is going to be 1/3 to the 4th, right? Which is 1/9 squared, dot dot dot. And now I notice I have the same infinite series. It happens to be a geometric series, right, in both terms. So I factor out S2 is going to be 1 minus 1/3 times 1 plus 1/9 plus 1/9 squared plus dot dot dot. And this is clearly a geometric series where r is equal to 1/9. So this whole thing converges to 2/3 times 1/1 minus r, which is 1/9. This will be 2/3. And this is going to be 8/9, and when I flip it, it'll be 9/8, right? And do a little bit of cancellation here. I'll have a 3 and a 4. And now for my final answer, I'm going to add these two, right? So S is equal to S1 plus S2. And we said S1 up here was 10 plus, and here we got 3/4. And so that's my answer. And you could leave it either way. You could leave it as 10 3/4 or 43/4, whichever you prefer.